Assalamualaikum and hi everyone. Let's learn about mathematics. Today, we are featuring a video assignment of SMG3013 geometry. So, for this assignment, we need to choose one of the structure or building around UTSI that meets the geometrical shapes and concepts that we learned in class. So, we decided to make an investigation of the signboard Sitc Hall. So now, I am standing in front of the Sitc Hall that has been established since 1922. It was initially founded to train Malay teachers for vernacular school within the British colonial administration. This signboard is placed right at the front entrance of Sitc Hall. It is easy to see because it is located along the main walkway, which is often used by students and staff. It is also near the open field where the students play sports like football and rugby. Its main function is to help the visitor, staff, and students easily identify the Sitc Hall. This is important because the campus has many buildings that are close to each other. The signboard is part of the campus navigation system and make it easier to move around. The structure of the signboard is a cuboid shape with height 204 cm, the length is 82 cm, and the width is 15 cm. Other than the main shape, the signboard also includes geometric features. We can see shapes like rectangle, pentagon, hexagon, and trapezoids. The shapes are part of the decoration and add variety to the overall design.
Next, we move to 2.1, the geometrical shape. Based on the structure we choose, we can identify 4 two-dimensional shape and 1 3-dimensional shape. The first 2D shape is rectangle. As we know, rectangle is a parallelogram where both pair of the opposite side are parallel and equal. Also, all the angles of rectangle is a right angle or 90 degree in measure. The next shape is pentagon. Pentagon has 5 sides, and this pentagon known as irregular pentagon because it has 2 distinct pairs of congruent sides. The third 2D shape is hexagon. Hexagon is a polygon that has 6 sides and 6 interior angles. It's also known as irregular hexagon, where it has 3 distinct pairs of congruent sides. And the last 2D shape is trapezoid. It is quadrilateral with exactly 2 parallel sides known as its bases. This trapezoid also classified as isosceles trapezoid, where 2 legs are congruent. And the last shape is a 3D shape, which is cuboid, or also known as a rectangular prism. A prism has 6 rectangular faces, 12 edges, and 8 vertices. Each face of the rectangular prism is a rectangle, where the opposite faces are parallel and equal in size.
In geometric concept, we will explain about the length of the side of the object, angles, how to get perimeters, area, and volume of the object. First geometric shapes is rectangle. So in rectangle, there are 4 sides which are AB, BC, CD, and EA. AB equals to 71 cm, BC equals to 26 cm, CD equals to 71 cm, EA equal to 36 cm. There are 4 angles that have equal measure, which is 90 degrees. To get perimeter, you have to get a total of all the measurement of the sides. So the perimeter is 194 cm. To get area, you have to multiply with length and width. So to the area of square is 194 cm. Secondly is pentagon. In pentagon, there are 5 sides which labeled as EF, FG, GH, HI, and IE. EF have 80 cm side, FG 70 cm, GH 70 cm, HI 18 cm, IE equals to 22 cm. There are 5 angles with measure of 90 degree, 140 degree, 80 degree, another 140 degree and 90 degree. Perimeter is 92 cm. Area of pentagon is calculated by breaking into two parts of shape, which are triangle and rectangle, and total the area of those two parts. So to calculate area of triangle, we have to use Heron formula. But before that, we have to calculate semi-perimeter. So semi-perimeter formula is total perimeter of triangle divided by 2. After getting the semi-perimeter, now we can use Heron formula, which is area equals to square root of semi-perimeter times semi-perimeter minus A times semi-perimeter minus B times semi-perimeter minus C. Triangle area is 142.57 cm square. Then we calculate area of rectangle and we get 396 cm square. Total those two area and we got 538.57 cm square. That is the area of pentagon. Hexagon have 6 sides which measure 7 cm, 3.5 cm, 9 cm, another 9 cm, 3.5 cm and 7 cm. Angles of 100 degree, 130 degree, 110 degree, 140 degree, 110 degree, 130 degree. Perimeter of 39 cm. To get the area, we have to cut the shape into 4 triangles. Each area is calculated using formula area equals to 1/2 AB sin C, where AB is 2 sides and C is the angle. The area of each triangle are 8.04 cm square, 38.06 cm square, 26.03 cm square, 8.04 cm square. Total of all the area of triangle is 80.17 cm square. That is the total of hexagon. Trapezoid I have 4 sides which measure of 88 cm, 57 cm, another 88 cm and 143 cm. 4 angles measure of 60 degree, 120 degree, another 120 degree and 60 degree. Perimeter equal to 356 cm. To calculate area of isosceles trapezoid, the formula is 1/2 times height times total addition of top base and bottom base. So the total area is 8,200 cm square. For cuboid, there are 4 sides equals to 82 cm, 4 sides equals to 50 cm, 4 sides equals to 204 cm. All angle equal to 90 degree. Perimeter of 1,204 cm. To calculate for area, first we have to search for lateral surface area, which equals to height times perimeter of the base. After that, we can calculate using formula area equals to lateral surface area plus 2 area of the base. Area of the base is using similar formula as area of the rectangle. The area of cuboid is 42,036 cm square. To calculate volume, we have to use standard formula, which is volume equals to length times width times height. The volume is 250,000 and 120 cm cube.
Transformation in motif and pattern. There are 3 types of transformation. The first one is rotation. Rotation of object according to degree of rotation, clockwise or anti-clockwise point on their center. There is no change in size or shape. Second, translation. Moving of every point in an object with the same distance and direction. There is also no change in shape and size. The third one is reflection. flipping the object and forming image based on line of reflection. The shape of image is the same in shape and size but appears reversed from the object like below. Next, I will show the transformation in motif from Sitc signboard. First, reflection. The reflection in the pattern show flipping a whole group of rectangles, which enhance the visual symmetry of all design. The concept of reflection occurs through the vertical axis of reflection in motif and produce the image of a similar shape and size. The second one is rotation. The transformation in motif from the Sitc signboard rotation. The rotation of 45 degree repeated many times until it creates a motif. The result of repeating rotation from a flower that radiates the bloom rotate around the center point. Lastly, the transformation in pattern that I found is reflection. This pattern remains in many shapes, which is pentagons, diagram, and flower. Beside it also has a similar size. Based on figure below, explain how the concept of reflection occurs through the vertical axis of reflection.
In part A of our project, we introduced the Sitc Hall signboard located at the main campus UPSI in Tanjung Malim, and note that Sitc Hall was once of the Malaysia first teacher education facilities. We also described the signboard location, which is near a main pedestrian path and sport field that also helps pupils easily locate the buildings. However, it simply looks like the signboard has significant culture and symbolic, so we also include detail about its size and structure, which mainly take the form of a cuboid and identify decorative elements made from other shapes like a trapezoid, rectangle, hexagon, and pentagon. While in part B, we focus on the signboard geometry, we discuss about the character of both 2D and 3D shapes, including the area, volume, perimeter, number of sides, and angle. We compute measure using established formula and related them to real-world transformation concept of rotations and reflections are used in the signboard pattern and motif. In addition, these all modifications also give a design symmetry and visual balance by highlighting the useful applications of geometry, especially in design and cultural symbol. This project also illustrates close connecting between a mathematics and the real world. Through this research, our group discovered that geometry is not just a learning subject, but also something that we can observe and use in every situation. This project gives us the meaningful learning experience as we explore the geometric pattern found in the Sitc Hall signboard. This requires us to think critically and choose an object that we could easily observe and measure as a group. To ensure that everyone participates actively to these assignments, we distribute the work across all the members. Then we also recognize a variety of forms, including rectangle, trapezoids, pentagon, hexagons, and cuboid by looking at the Sitc Hall signboards. These shapes are used to make the signboard strong, attractive, and easy to understand. Through these two, we realize how geometry plays an important role in design, structure, and everyday objects around us.